Hello dear students, here I am going to discuss a simple trick to find out the hybridization of any molecule within few seconds. For this, we have a simple equation that is what half into V plus X minus C plus K, where V is the valence electron of the central atom and X is the number of monovalent atom, that is the atoms with the valency 1, that is like hydrogen or halogen, and C is the magnitude of the positive charge. For example, suppose if you have that species have the charge plus 2, you have to take only 2, no need of plus. Similarly, A is the magnitude of the negative charge. For example, suppose CO3 2 minus, the charge is minus 2, but you have to take only 2. So that is what A, the magnitude of negative charge. So if you apply these things in this equation, you are getting some simple numbers like 2. If it is 2, hybridization is sp and shape is linear. Then if it is 3, the hybridization is sp2 and shape is trigonal planar. This is trigonal planar shape. You can see it is trigonal planar, like samosa, samosa, triangular, okay. If I keep this in my palm, all the atoms touch the palms. Okay, so trigonal planar. Okay. Similarly, if we are getting the number 4, hybridization is sp3 and the shape is tetrahedral. This is that tetrahedral shape. You can see this is tetrahedral, bond angle is 109.5 tetrahedral. If I keep this here, 2 atoms are in one plane, one is forward and another is backward. So this is what tetrahedral shape. All the angles are 109.5. Okay. Now, if I get the number 5, the hybridization is sp3d, then the shape is trigonal bipyramid. Trigonal bipyramid. This is that trigonal bipyramid. You can see this is a triangle and one up and one down. This angle is 120 and this angle is 90. This is trigonal bipyramid shape. If you are getting the number 5, the hybridization is sp3d and the shape is trigonal bipyramid. Similarly, if you are getting the number 6, the hybridization is sp3d2 and the shape will be octahedral. You can see this is what octahedral shape. All the angles are 90 degree. All the angles are 90 degree. Why it is octahedral? If you make like a tent, on the top you can see 4 sides and at the bottom also you can see 4 sides. Total how many sides are there? 8 sides. That's why it is known as octahedral. So this is octahedral shape. Here. Now see, the shape, this shape is correct if the molecule doesn't have a lone pair. Okay. Hybridization is always correct. If you are getting the number, this number hybridization will be always okay. But the shape is correct if the molecule doesn't have a lone pair. If there is a lone pair, there will be a little change in the shape. That we are going to discuss now. Now suppose you are getting number 3 and the molecule contain one lone pair, then the shape is not trigonal planar, instead the shape is bent. Then how we can know whether the molecule contain lone pair or not? I will tell you. Okay, so this is that shape. You can see this is that shape. Actually this was trigonal planar, but here we have a lone pair. So when the lone pair is there is no bond, we can consider only these 2 bonds, then the shape will be bend. Okay, so this shape is bend. Now if we have 4, we are getting the number 4 and one lone pair is present, then the shape is pyramid like ammonia. This is trigonal pyramid like ammonia. Now don't get confused. This is trigonal pyramid, this is pyramid, this is trigonal planar. What's the difference? You can see here. All the atoms touch my palm. Here only the 3 atoms touch my palm and the middle one is some little up. That is what pyramid shape. So this is trigonal planar, this is pyramid shape. Okay. Now if you are getting the number 4 and the shape 2 lone pair present on the molecule, again the shape is bent. For example, water molecule. You can see this is that shape. See, actually we had 2 bonds here, one here, one here. Then the shape becomes tetrahedral, but these 2 bonds is replaced by lone pair. So the shape is becoming bent. In H2O, this is oxygen, this is 2 hydrogen, 2 lone pairs are there on the oxygen. So this is bent. So 4 we are getting, but 2 lone pair present, then the shape becomes bent. Clear? Now we are getting the number 5, then the hybridization is sp3d, not change. But if it contain one lone pair, the shape will be seesaw. You know seesaw? So this is that shape. See, this is that shape. See, seesaw like this. Here, this is lone pair. Actually, it was trigonal bipyramid. See, trigonal bipyramid. But here we have a lone pair. So you can forget this bond. Here we have only that 1, 2, 3, 4 bond. So the shape will be like this. Okay, seesaw shape. This is lone pair. Okay, if you have a bond here, then it becomes not trigonal bipyramid. Here, so if we are getting 5 and 1 lone pair, the shape will be seesaw. Again, now if we are getting 5 and 2 lone pair, 5 and 2 lone pair, it will be somewhat like T shape. T shape. This is that shape. You can see this is T. That is T. Okay, letter T. Actually, it was trigonal bipyramid, but here we have 2 lone pair. So 2 lone pair replaces 2 bond. So forget this bond, then the shape will be what? T shape. Here, it's okay. Now, if we are getting 5 and 3 lone pair, 5 and 3 lone pairs are there, then the shape will be linear. Shape will be linear. It will be like this. Actually, it was trigonal bipyramid. See, 3 bonds here in this equatorial position and 1 up and 1 down. But these 3 equatorial position bond replaced by lone pair. So the shape is not linear. This is lone pair. So the shape becomes linear. So 5 we are getting and 3 lone pair. 3 lone pairs are there. Then the shape will be what? Linear. So this is what? Okay. Now we are getting 6 and 1 lone pair is present. 6 and 1 lone pair is present. Then what happens? Let's see. 6 and 1 lone pair is present. It will be somewhat like square pyramid. Square pyramid. Actually, it was octahedral. If we have a bond here, it becomes not octahedral. But one bond is replaced by lone pair, so it became what? Octahedral. I mean square pyramid. Square pyramid. Okay. Now we are getting 6 and 2 lone pair. Then it will be square planar. Square planar. See, this was octahedral. In this octahedral, these 2 bonds are replaced by lone pair. So if you replace this, it will be somewhat square planar. Square planar shape. See, this is the shape. Square planar shape. Okay. Now you got, see, this. If you are getting this number, hybridization will be always okay. But shape is correct. This shape is correct if there is no lone pair. If the molecule contain lone pair, the shape there will be change, but there will be no change in the hybridization. Hybridization will be always same. Now, how we can know whether the molecule contain lone pair or not? Let's see. Some examples I have given here. We can solve it. First, we can check CH4. In CH4, you can see central atom is carbon. So, R into valence electron of the carbon is 4 plus monovalent atom X. 4 hydrogens are there. There is no negative or positive charge. 4 plus 4, 8. 8 by 2, then it will be 4. So we got the number 4. So the hybridization is what? sp3. Now we can check the shape. Let's see how we can know whether this molecule contains lone pair or not. What number we got here? We got the number here what? 4. The peripheral atom number. After central atom we have peripheral atom. Peripheral atom is also 4. If the number we got as well as the number of peripheral atoms are same, there is no lone pair. So if there is no lone pair, the shape is tetrahedral. Shape is tetrahedral. Okay, now we can check ammonia. Ammonia, which is what is the central atom? Nitrogen. Atomic number 7, valence electron is 5. 5 plus 3. Monovalent atom 3. There is no positive or negative charge. 5 plus 3 is what? 8. 8 by 2 is what? 4. So we got the number 4. So hybridization again, what? sp3. Because we got 4. Now, we got the number 4, but the peripheral atom is only 3. So 1 is less here. Peripheral atom 3, we got the number 4. 1 difference is there. What does it mean? That molecule contains 1 lone pair. Okay, if the difference is 1, the molecule contains 1 lone pair. So we got the number 4. 4 plus 1 lone pair. Pyramid. Ammonia is pyramid shape. We know that. It's okay. Now come to another molecule, CO3 2 minus. CO3 2 minus. Let's see. Half into central atom is what? Carbon. Valence electron is what? 4. Number of monovalent atom. Oxygen is not a monovalent atom. No need to count it. Number of monovalent atom is 0. Positive charge. Magnitude of positive charge is 0. Magnitude of negative charge, yes, 2. 4 plus 2 is what? 6. 6 by 2 is what? 3. 3. We got number 3. Number 3 means the hybridization is what? sp2. Now, what's the number we got? 3. Peripheral atom is also 3. Those no lone pair. So the shape is trigonal planar. So CO3 2 minus is trigonal planar in shape. Now we can check NH4 plus. In NH4 plus, we can see half into central atom is what? Nitrogen. Atomic number 7. Valence electron is 5. 5 plus monovalent atom is what? 4. 5 plus 4 is 9. Now positive charge magnitude. What is the magnitude of positive charge? Plus 1. So minus 1. So we are getting 8. 8 by 2 is what? 4. So we got the number 4. Okay. Now hybridization is what? sp3. If we get number for hybridization is sp3. Now what is the shape? Let's see whether the molecule contains lone pair or not. What number we got here? 4 number. What is the number of peripheral atom here? There is also 4. So both are same. There is no lone pair. So the shape is again tetrahedral. Now we can check ClF3. Any molecule you can check ClF3. Which is central atom? Chlorine is the central atom. Chlorine is the halogen. Halogen valence electron is 7. So half into 7 plus monovalent atom, halogen or hydrogen. How many halogens are there? 3 halogens. Chlorine is central atom. Then after that, how many peripheral atoms are? 3. So that is monovalent is 7 plus 3. 7 plus 3. 7 plus 3, 10. 10 by 2 is 5. So we got the number 5. If it is 5, the hybridization is sp3d. sp3d. Now what we have to find out the shape. For this, what number we got? 5. 5 we got, but the peripheral atom only 3. Peripheral atom only 3. That is the difference 2. So 2 lone pairs are present there. So 5 plus 2 lone pair. 5 plus 2 lone pair. T shape. So this molecule ClF3 shape is what? ClF3 shape is what? T. Okay. Now any other molecule you can check. BF3 we can check. BF3, which is a central atom boron. Half into central atom boron, atomic number 5. Valence electron is 3. How many? Monovalent atom. 3 monovalent atom. 3 plus 3. There is no positive or negative charge. 3 plus 3 is what? 6. 6 by 2 is what? 3. Okay. So hybridization is what? sp2. Now what's the shape? Let's see whether the molecule contains lone pair or not. What is the number we are getting here? 3. What's the peripheral atom? That is also 3. There is no difference. So no lone pair. So the shape is trigonal planar. It's okay. Now we can have another example, that is I3 minus. I3 minus we can write as what? I2 minus. Am I right? Yes, because one atom should be central. So iodine is the central atom. Valence electron is what? 7. So half into 7 plus peripheral monovalent. Iodine is monovalent minus 1. So 7 plus 2. 2 monovalent atoms are there. Now minus magnitude of positive charge 0, magnitude of negative charge 1. So 7 plus 2, 9, 9 plus 1, that is 10. 10 by 2 is what? 5. That is 5. We got the number 5. So the hybridization is sp3d. sp3d. Now what is the shape? We got the number 5, but the peripheral atom only 2. One we took as central atom, then another one is what? 2. Okay, so what's the difference? 3. We got the number 5, peripheral atom is 2. Then difference is what? 3. Difference 3 means 5 plus 3. Shape is what? Linear. So the molecule is what? Linear in shape. Linear in shape. Now last one you can see XeF4, xenon, fluoride, tetrafluoride. Xenon is the noble gas. So valence electron is 8. So half into central atom xenon. Xenon is a noble gas. So valence electron is 8. Plus monovalent atom is what? Monovalent atom 4. 8 plus 4 is what? 12. 12 by 2 is what? 6. So we got the number 6. So definitely the hybridization is sp3d2. sp3d2. Now see, we got the number 6, but peripheral atom only 4. What's the difference? 2 is the difference. It means we got 6. The hybridization is what? sp3d2. But since 2 lone pair present, how we came to know 2 lone pairs are present? We got the number 6. Peripheral atom is what? Only 4. So the difference is what? 2. So 2 lone pairs are present. So the shape is what? Square planar. So XeF4 is a square planar molecule. In this way, we can easily find out the shape and hybridization of any molecule within few seconds. We can see again with another trick in another video. Okay? Thank you.